Howdy, I'm Mr. Robinson, and I'm going to walk you through page 47, numbers 4 and 5 from your packet. These are what I call proportional reasoning problems because they're basically asking you to find or create a proportion with a couple of variables. It's saying change one, what happens to the other, that's a proportion. I've got some steps written down here, so I'm going to follow the steps and show you how to complete problems 4 and 5. So we start with picking an equation with both variables. Okay, well, I don't see any variables listed here, so let's read the problem. How many times faster, twice as fast, 3 times as fast, etc., would you have to jump in order to jump twice as high? Show your work. Well, how many times faster? All right, if you're jumping with a velocity, that's going to be the velocity you start with for your v-naught. If you're going twice as high, this is vertical motion. So I'm going to call this the delta y. So look in your kinematics equations, find an equation that has both of those things, and pick one. And I'll tell you some more rules in a little bit. The one that I'm going to use for this one is v squared equals 2a delta y, again using the y because it's vertical motion, plus v naught squared. Okay? Now, I picked this one because when I change one variable, it's not going to change the other one in a free fall, and here's why. What's my velocity at the top of a throw up, throw down, or the top of a jump? It's going to be 0. So this velocity here is 0. The acceleration for a free fall, well, that never changes. We showed that in the lab. It's always going to be the same. So this is the one I'm going to stick with. Now, I'm going to do step 2 here. Rearrange so the variables are on either side of the equals sign. So all I'm going to do is take this velocity and put it over here so that my v naught, my delta y are on opposite sides of the equal sign. Now, I left a little space in here, and you'll see why in the next step. Balance the equation for the variables. Okay, so I'm going to put a little placeholder here and here, and I'm going to put a parentheses just around the variables that I'm talking about for the proportion. And then we're going to do what the problem asks us to do. How many times faster? Twice as high. Okay, so if I double this, what happens to velocity? Now, a lot of you are probably saying, hey, if that's a 2, that should be a 2 equation balance. But if you put a 2 in here, it would actually be 2 squared. Because see, whatever you're doing to the velocity, you're kind of doing it twice. So 2 squared would be 4. So that's not balanced. So believe it or not, whatever you put in here, squared has to equal 2. Well, the square root of 2 squared equals 2. So this is actually what I'm going to put here to be a square root of 2. So basically, step 4 would be to write out the proportion as a sentence. If you jump twice as high, then you jumped root 2 times as fast. Or if you like just numbers, root 2 is about 1.4. So in other words, to double your height when you jump, you'd have to jump about 1.4 times as fast. And that's the solution for that problem. Looking at number 5, I'm going to go through the steps right again. So pick an equation with both variables. Okay, let's look. How many times faster? Hey, that's our old buddy, v naught. Would you have to jump in order to double your hang time? All right, well, that's going to be t. So if you look through your kinematics equations, you can pick an equation that has v naught and t. So I'm going to pick velocity equals acceleration times time plus v naught. Again, you're jumping, so at the apex of your jump, at the very tippy top, this velocity is going to be 0, so we don't have to worry about it too much. And then I'm going to start with step 2. Rearrange so the variables are on either side of the equal sign. All right, I'm going to take v naught, I'm going to put it on this side again, equals acceleration times time. I'm going to space this out a little bit more. For step 3, balance the equation or the variables. All right, I'm going to put a placeholder here, nice parentheses, because I always do. Let's see, what did it say? How many times faster if you double your hang time? So if I double my hang time, what would happen over here? Well, there's no exponent this time. So if I double my hang time, if I double this value, I'm going to double this value also. So the answer here is going to be 2. So basically, step 4, writing out the proportional sentence, if you double your hang time, then you jumped twice as fast, or 2 times as fast. That's how you do proportional reasoning problems. Sometimes the hardest step is picking an equation with both variables that's not going to change any other variables. And sometimes to do that, you actually have to use kind of a substitution of equations. So if you want to get time out of there, you have to use another kinematics equation to rearrange for time, and then plug it into a different equation to remove time from it. Good luck. We'll be doing these more and talking about it. See you Tuesday.